You know that feeling when you're talking to an AI and it just gets you? It feels like magic, right? Well, today we're going to pull back the curtain on that trick. We're breaking down how machines are actually learning to master the one thing that makes us human, our language.
Yeah, I bet you have. I mean, think about ChatGPT. You type something in, and bam! A perfect, coherent answer just pops up. It's like talking to a real person. But how? How does a computer turn a jumble of letters into something that actually makes sense?
So the answer isn't magic, of course. It's a really cool field of science called computational linguistics. Think of it as the bridge connecting our human language to computer code. And honestly, it's the engine driving this whole AI revolution we're living through right now.
All right, so let's break that down. At its core, computational linguistics is pretty much just about teaching computers how to read, understand, and even spit out human language. It's this wild mix of linguistics, computer science, and AI. And believe it or not, people have been working on this stuff for decades.
Okay, so if you want to teach a computer language, you can't just, hand it a dictionary and wish it luck. No, first you have to break our language down into rules and patterns that a machine can actually compute. It needs a system.
Here's a good way to think about it. Imagine language is a house. You can't just toss a pile of bricks and wood on the ground and call it a day, right? You need a blueprint. You got to understand the foundation, the frame, the wiring, all the layers that have to work together. Well, language is built exactly the same way.
And this right here, this is the blueprint. Linguists have broken language down into these 5 main layers. You've got phonology, which is all about sounds, morphology, which is how words are built. Then there's syntax, that's your sentence structure. Semantics is the literal dictionary meaning, and pragmatics, that's all the meaning that's hidden in the context. Now, for what we're doing today, understanding how computers read, we're going to zoom in on 2 of the big ones, morphology and syntax.
All right, first up, morphology. This is all about the tiny, meaningful building blocks of words. You know, things like prefixes, un, or suffixes, ion. A computer has to learn that happy and unhappy are related but opposites, and that run and running are basically the same action, just in different forms. These little pieces are called morphemes. They're like the atoms of meaning in our language.
Next, we've got syntax. And this is basically the grammar you remember from school. It's the rulebook that says the dog chased the cat makes sense, but chased dog cat thee is, well, it's just gibberish. For a computer, syntax is absolutely crucial. It's the set of instructions for how to assemble words into something meaningful. Okay, so we've got the blueprint. Now let's get to the fun part, how a computer actually puts it all together to read. This is where we step into the world of natural language processing, or NLP for short. This is the how-to guide, the step-by-step process for analyzing language.
We're going to use a simple sentence to see how this works. Her clever dogs were running. To you and me, that's super simple. But to a computer, it's just a raw string of data that has to be pulled apart piece by piece. So the very first thing a computer does is it chops that sentence up into individual units. This process is called tokenization. It's basically just creating a list of every single word and, yep, even the punctuation. And this is what you get. See that? Even the period at the end is its own little token. To a computer, every single piece of data matters. Breaking it down like this is the first absolutely critical step before it can understand the sentence's structure.
Okay, next up, the computer has to figure out the root of each word. And there are 2 main ways it can do this. You've got stemming, which is kind of the fast and dirty approach. It just hacks off the ends of words. But then you have lemmatization, which is way smarter. It actually looks at the context of the word to find its true root, or lemma. So you can see here, stemming might turn were into the nonsense word were. But lemmatization is smart enough to know the root is the verb to be. And why does this matter? Well, good lemmatization is the reason why, when you search for best running shoes, Google also knows you might be interested in stuff about the verb to run. It just gives you way better results.
So once the roots are figured out, the computer does something called part-of-speech tagging. This is exactly what it sounds like. It goes through and slaps a label on every single token. This is a noun, that's a verb, this one's an adjective, you get the idea. This whole process creates a grammatical map of the sentence, which lets the machine finally start to see how all the words relate to each other.
All right, I know that was a little bit in the weeds, a little technical. So you might be asking, why do I care about any of this? Well, here's why. These basic steps, tokenization, lemmatization, tagging, these are the absolute bedrock of the AI you're probably using every single day. Think about it. Your phone's voice assistant, Google Translate,
All of it, these incredible technologies are all built on these same core ideas. Let's look at a couple of real-world examples. Take machine translation. When you pop a sentence into Google Translate, it's not just doing a word-for-word dictionary lookup. No way. It's doing a deep dive into the syntax of your sentence, figuring out the subject, the verb, the object, and then it tries to rebuild that exact same meaning using the grammar rules of the new language.
Or what about this? Let's say you're a company, and you've got to sort through thousands of customer reviews, just like this one. How on earth do you get a quick read on what people are actually feeling?
Well, the answer is sentiment analysis. You train a machine to know that words like best and insightful are positive, and words like terrible or boring are negative. Then it just scans the review, tallies up the score, and gives you an overall sentiment. So for this one, the verdict is obviously positive. And companies use this on a massive scale, to track what people are saying on social media or to analyze thousands of product reviews in the blink of an eye. And all of these pieces we've been talking about, tokenization, syntax, word roots, they all come together to power the #1 AI application that everyone is talking about right now. Yep, the powerhouse itself, ChatGPT.
But for as powerful as these tools have become, the job is nowhere near done. Teaching a machine to truly understand our language is a marathon, not a sprint. And there are still some huge hurdles that researchers are working on right now.
For one thing, our language is just full of ambiguity. Take a sentence like, I saw a man on a hill with a telescope. Okay, so who's got the telescope? Me or the man? Our brains use context to figure that out instantly, but for a computer, that is incredibly difficult. And that's before we even get into things like sarcasm, irony, or cultural jokes. That's a whole other level of complexity.
So, as we keep building these machines that can pick apart and actually understand our language, it kind of leaves us with a fascinating question to chew on. See, in order to teach an AI how we talk, we're basically forced to create a perfect, logical blueprint of our own language. So the real question is this: as AI gets better and better at understanding our language, will we get any better at understanding ourselves?